Hi everyone, welcome to Mobile Development for iOS and Android Virtual Developer Day, brought to you by the Oracle Technology Network. My name is Joe Huang, and I'm part of the Mobile Application Development Tools team here at Oracle. This session will focus on Data Services Layer for Oracle ADF Mobile. First, a disclaimer that any information around future direction of ADF Mobile is intended for information purposes only and are subject to change. Well, let's look at the data layer within an ADF mobile application. As discussed previously, ADF mobile applications are running inside a native container as a native application. Within this native container, the data services are highlighted in blue. First, we have the Java virtual machine that provides the runtime environment for data services within an ADF mobile application. Inside the JVM, we have a mobile implementation of the ADF model component that provide key data access services. There are any number of Java programs a developer would write that provide business logic. Also JDBC APIs that allows the business logic and ADF mobile components to interact with the local SQLite database. On the server side, you would have SOAP and REST services that integrate server-side component with the ADF mobile application. Well, let's take a look at what data sources are supported by ADF Mobile. For data sources residing remotely, for example on a server in the cloud, SOAP, REST XML, and REST JSON services are supported. But when there are needs to cache and access data locally, ADF mobile application can consume data through Java classes and local database. As a matter of fact, generally ADF mobile application access data through Java objects, whether the data is coming from SOAP, REST, or local SQLite database. Declarative data access is supported for certain data services, although in the majority of the cases, it will probably access data through Java objects. Well, now let's take a look at the roadmap to define data services for an ADF mobile application. First, you always start with determining functional requirement for the application. For example, what does the application do? Instead of trying to fit the application to some existing backend data services, you will always start with understanding what the application should do before determining how the application should access data. Another critical factor is understanding the availability and performance requirement. For example, does the application need to work without network connection? And even if the application is expected to operate only with network connections, are there functionality in the application that must perform quickly without requiring network round trip to the server? These requirements will dictate how you design your data services layer. Now, once you understand the functionality, performance, and availability requirement, you can then determine what data services protocol is best suited for the application and whether local caching, data caching is needed. You can then determine which services can be accessed entirely declaratively and which services require accessing through Java code. Another key to defining data services is that you would typically want to create Java-based data services first, before connecting the application to server-side services through web service. This allows you to fully design out the details of a mobile application and run the mobile application and as a prototype using the data coming from Java-based data services modules. You can then use this information to determine server-side data services. Well, to help you with designing data services layer, here are some best practices we have learned from current ADF mobile developers. First thing is, it's critical to think mobile first and consider exactly how data should be accessed from the mobile device. This typically requires you to optimize server-side data services for access by mobile applications. For example, a mobile application may only access a small chunk of data at one time, and therefore require server-side web services to support such interaction. However, most existing web services, be it SOAP or REST, are frequently optimized for server-to-server interaction. Server-to-server interaction typically favor requesting large chunks of data in one shot because server-side application can cache data and then display these data efficiently to desktop browser users. As a matter of fact, as a rule of thumb, you should avoid using existing web services designed for server-to-server communications. You should also need to take a multi-layer approach to integrate with backend data. Therefore, you may have two layers of server-side services. One layer supports mobile application data access, and another interact with backend enterprise applications. Oracle Fusion Middleware can easily support this multi-layer approach. For example, Oracle SOA Suite and BPM can perform data transformation that's needed between the mobile-facing and server app-facing layers. Enterprise Service Bus, or ESB, can in turn transform any web service protocol into mobile-optimized REST JSON services. As a matter of fact, you should consider Oracle Fusion Middleware to be a critical part of a complete mobile platform. Well, now let's look at the data caching requirements. You may decide to cache data locally on devices for availability and performance consistency reasons. For example, for field service type of application, users typically will access application without network connectivity. This does require additional effort to integrate or develop the data synchronization modules. If the application requirement does call for caching data, then there are some key factors to consider. First, you need to consider whether to cache the data as user request data, or is there a specific data synchronization functionality to cache data in one batch. This typically is determined by whether the mobile application is mostly connected or occasionally has network connection. Next is to consider how much data needs to be cached, which is really determined by the amount of data the user needs between data synchronization. Another factor to consider is when to upload updates. Another factor to consider is whether the order of the update is important. The simple example is in create an update operation. Creating a record must occur before the update, and therefore an application logic must account for that. Lastly, you should consider the potential of data theft due to lost devices. This would typically mean you should consider encrypting the local database and add offline authentication functionality to the application. Now, let's look at a few possible data services scenarios. The first one is always connected. This means reads and writes use live web services and no data is cached on the device. Obviously, this does not provide any offline usage, and there's a lot of potential latency in the application. This method is easily accomplished with ADF Mobile today. Second type is data reads are cached and writes are online. So when web service is invoked, the developer caches the data into a local database on the device. When it's offline, the device can go off the local data store. Write, however, requires direct web services call and therefore can only be done when the device has a connectivity. This avoids any requirement for dealing with potential data conflicts. And again, this can be easily accomplished using ADF Mobile today. And many of the applications are built using this method. The third type is read data are cached and offline writes are locally saved to a local database and synchronized later. So just like the previous scenario, the reads are cached and then when it's offline, the data can be accessed. However, this adds the notion of being able to update on these records while offline, and also writes are cached locally as transaction to be replayed later. The update is stored on the device, and then at a later time when there's that connectivity, the change is propagated up to the server and then replayed. And then the last scenario is a true data synchronization where the data needs to be synchronized back and forth between client and server. And there are a number of Oracle products, such as Oracle Mobile Database, Database Mobile Server, that support full database synchronization. Okay, let's take a look at different protocols supported for server data access. First is SOAP. SOAP is a popular web services protocol for enterprise web applications. You can consume SOAP web services using Web Services Data Control Wizard, and you must specify a WSDL file while creating the web service. SOAP web service can be invoked declaratively. In other words, application UI can correctly invoke SOAP web services without requiring developer to write any code. However, developer can still access SOAP web services in Java using the ADF Mobile Java Data Control APIs. Another common web service protocol is REST XML. XML data source must have a corresponding XSD that defines the format or schema of the XML data. Similar to SOAP, REST XML data can be invoked declaratively or using the ADF Mobile Java Data Control APIs. Lastly, a protocol that's very popular with mobile application is REST-JSON. Consuming REST-JSON data source requires the creation of a URL connection using the URL connection wizard. URL connection defines the host name for the JSON data source. There's only Java APIs available to access JSON data, so you must write Java code to access JSON data. REST services adapter Java APIs and parser classes or helper classes provide easy access to consume JSON data from the Java code. Okay, now we have discussed option to consume server-side data. Let's look at how to expose this application data to user interface through Java code. Though we have a lot of options to write Java code to access data services, it is generally best practice to write a dedicated set of classes to access data. Of course, you can access data through backing beans, but generally that will create issues down the line as it mixes UI operations and UI layer with the data layer. Furthermore, you will generally want to create these Java data objects first, so you can actually build out a prototype of your application backed by these Java objects. This way you can work out your user interaction and data requirement first before designing and implementing your server-side data services. There are generally two sets of Java objects you will create for your data layer. First is what we call service object. Service object is a Java class that's used to define CRUD operations on an object. There's no specific interface for this object, and its definition is really left to developers. It is something that we define its definition so we can reference what a different type of Java object you need to create. It is typical for a service object to use JDBC to access a local data store, or use web service to get its data, and then erase the data object to be returned. A service object is also a class that a developer will create a data control wrapper on to expose its method in the data control palette. Now, data object is a Java class that's defined as a data holder for the object. It represents a single row of data and defines the attribute with appropriate getter and setter for the data. It does not itself do the retrieval of the data from another store. It is typically defined data hierarchies. So for example, a data object may contain simple attributes such as strings, or complex attribute is other data object that are basically child of this data object. Here's another important concept for any ADF or ADF mobile application. All ADF and ADF mobile applications access data through a common data abstraction layer called data control, which exposes data to the user interface. Data control is a wrapper that allows the framework to bind to data in an abstract way regardless of its source. The data can be Java class, a web service, or any other source. The data controls.dcx file contains the list of all data controls defined for the project. Data controls are visualized in the data control palette, which allow developers to drag and drop from there to the source or structure pane in order to create data-bound components. For ADF mobile application, Bing data controls and SOAP and URL data controls are supported. Okay, let's look at the what we call service object a little bit more. Again, it's a very important concept in ADF mobile. First, service object is just a name, as there's nothing specific in a framework called service object. However, this is a critical concept and a good programming practice to implement. Service object is a Java class that returns a collection of data objects. The actual implementation of the data retrieval can be JDBC, to a SQLite database, access to REST JSON object via REST service adapter class, or invoking other data controls like web services data control or URL data control to invoke SOAP or REST XML web services. Service object can also use another Java method like file.io to retrieve data. Creating Java classes for data access is typically the first step you would do, as it will allow you to build a full functional prototype without connecting to the server. Now, once you figure out what server-side data you need and actually build out that server-side services, you will now be ready to take the next step. If you do decide to consume SOAP-based web services, you will simply go through the Web Services Data Control wizard to create a Web Services Data Control. You will need to specify the WSDL to web services. Please note that there is an option to copy WSDL locally in the wizard, which is the default. Checking this option would improve the performance of accessing web service during the application development by reducing the time for the very first time the web services is invoked after the application installation. And at the end of this wizard, a data control will be created for the web service. You can then drag and drop these data control to your AMX page directly or access them through Java APIs. To consume XML REST service, you will first create a URL data control using the URL data control or Web Services Data Control wizard. Please note that when you create the data control, do not enter authentication details even if the REST service is secured with user ID and password. Security is configured actually separately in the ADF mobile application. You will need to select an HTTP method for the REST service. Also, you can specify the path to complete the URL and parameters in the source field. The parameter can be set when data control is invoked. You also need to point to an XSD file that describes the REST XML data structure. To consume JSON REST services, you will need to create a URL connection that points to the JSON host server or the root of the JSON service. For example, in this example here, for JSON REST service that ensures employees and department, for example, server.port/service/employees and server.port/service/department, the URL data control should just point to the root of the JSON service, which is server.port/service. To actually invoke the JSON REST service, you will need to write some Java code. You will write data objects that describe the data structure, and then service object to invoke the JSON service and populate the data objects. You will then use REST service adapter utility class to actually invoke the JSON REST services. Now, let's look at a sample code to invoke the REST service adapter. In this code here, you'll first clear any previously set request properties if there are any. You'll go set the connection name. You specify the type of request, specify the number of retries, set the URI, which is defined after the endpoint in the connection.xml. The entire request is the endpoint plus the URI being sent. Then you execute the send and receive operations. And for GET request, there's really no payload to send. Now create a new REST JSON response object and parse the JSON string returned into this class. There's also an example of invoking REST JSON services in the ADF mobile team blog. Actually, we'll go through the sample application that's shipped both in the ADF mobile team blog and also in the JDeveloper sample together. Okay, let's actually go through the process of creating a data object and service object after we have covered it. We're also going to create an application to consume these data object and service object. So I'm going to go to New Gallery, select New Application, select Mobile Application, and click OK. And then what I'm going to do is name the application Virtual Developer Day Demo. Click Next. And I have basically a couple projects in the application. By default, the view controller project and the application controller project. View controller project is where I have application features and code in there, whereas the application controller project has application level artifacts. All right. So here I'm going to do is go to my view controller project, and again go to the new gallery and select new. I'm going to find Java, and I'm going to create a new Java class. Click OK. And I'm going to name this class emp. Basically, I'm going to create an employee object to store my employee data. Again, this is going to be my data object. So I'm going to first add my attributes. The first attribute is the employee name. Oh, I have a typo there. And the next one is going to be email. Next attribute or variable is going to be salary, and the next one is going to be, actually I think we have made a slight mistake. Actually salary should be an integer, so I changed the type to integer. And the next one is going to be the hire date. And as you can tell, we introduced a new type that's not yet supported, but there's a shortcut that I can simply add the import. There's a key combination, and basically I want to select the Java date utility to import into the application. Now I'm going to add the two constructors I need to access data. So first I'm going to use name and have name and email as the input parameter. Okay, fast forward this a little bit. I'm going to create my second constructor by copy and pasting it, and I'm going to add a couple of parameters to this. Okay, so I have a new constructor with the parameters. Okay, here's my new constructor for the parameter, and as you can see, as I type, I can see all kinds of hints popping up showing you what JDeveloper can do to support Java development, and you get this all for free. Now next I need to do is I need to generate the accessor, basically the getter and setter for all the attributes. So I'm just going to select all of the attributes, and I need to check notify listener when the property change. This is going to add all the Java methods that will propagate change to the user interface. We're going to explain this actually in the next lesson, but just remember when you create the Java class for data object, you should always check the notify listener when property changes. Okay, that's it. You have all the getter and setters and appropriate data change events API that's in the class. Next, we're going to create another Java object for my service object. Again, service object are the type of Java object that would populate and instantiate the data object. So I'm going to name this class amps, and here I'm going to cheat a little bit. Instead of typing everything in, I'm going to copy and paste some code in. And let's look at the code a little bit. Here in the code, basically I have get employees. In this Java class I have again employee method, and again employee method basically populates the employee data and put it into an array list. Then I'm going to convert that array list back to an array. Alright, so I need to declare an array amps and also declare a new array list. Then I have the logic that basically adds to the array list of the type data type object amp, right? And there's some data that populate. Okay, and then in the last step of the method, I need to convert the array list back into an array. The reason we need to convert it back to an array is the ADF mobile framework itself expects the data from a Java object to be in the format of an array. So you always need to convert it back from array list to an array. Okay, now let's quickly complete this application by first creating a data control based on a service object. Again, data control exposes data to the user interface. In this case, I simply right-click on the Java class emps and then create the data control. Once the data controls are created, I can define the rest of my application. First, I'm going to create a new feature to hold the employee screen, and believe we covered the part and we explained features and application in the previous session. And for this feature, we're just going to create a very simple task flow and with a single view. Again, we'll cover task flows and views in the next session, but for now, let's just go through this very quickly so we can actually look at the data on the screen. So I'm going to click OK. I'm going to split the screen a little bit to get a preview of what the application would look like. Okay, and then I will go ahead first change the header to say list, and that changes the preview right away. Then I'll open up my emps data control, and what I'm going to do is drag and drop the emps data from the data control palette into my structure pane. You can also drag and drop into your source. And then I'm going to display a couple of rows in the list view, and I'm going to display name and email. I'm also going to add some divider, and then I'm going to have the divider divide by the first letter. That's it. I'm going to save the application, and let's look at what the application looks like by deploying it to a simulator. Okay, application in the background is deployed, and the simulator at this point is starting up. Okay, and let's move to the screen with the application Virtual Developer Day demo. I'm going to click on it to launch it, and there you go. Here's the first screen containing the list of employees I populated in my data object. And as a matter of fact, just let me go back to my service object. I can see the data matches with what's showing on the screen. Well, okay, let's look at another example. So in this example is called REST demo. In the REST demo sample application that's shipped with JDeveloper, we're actually going to invoke a JSON REST service. We're going to see how the application works. So first, let me launch the app in the simulator, click on the REST JSON feature, and this is a simple application. Basically, I will type in an IP address or a domain name, and it's going to invoke a public REST JSON service that returns the location of that IP address. So I'm just going to leave the default oracle.com, going to click on search. Behind the scenes is invoking a JSON REST service to return the location of the IP address, and the oracle.com resolves to 137.254.120.50, and then the rest of the data comes from the JSON REST service that indicates the location. And also on the bottom here we'll have an output text that shows you the raw JSON format or return that's returned from the JSON REST service call. At this point, I can even look at and launch the geomap embedded in the application and look at the location of this particular IP address from oracle.com. Okay, now let's look at the code a little bit. So basically, there are two Java classes here that is worth discussing. One is my data object, which is this REST JSON response.java class. And basically you have all the attributes that would hold the data for the response for this JSON request. You know, the IP addresses and and the location and the city and so forth. And my service object is called REST JSON being. And if I scroll down a little bit, I see a load data method. Load data is where all the magic happens. It actually invokes the JSON service. And basically, as you could see, we invoke the REST Service Adapter API. So the first thing I need to do is basically declare a new object for REST JSON adapter and instantiate it. And then next step is I'm going to clear any previous request. Then I'm going to get the URL connection that basically points to the host name for this REST JSON service. Okay, let's look at open up the connection and URL connection, look at properties, and here we go. That's my URL endpoint that I would, or the host name I would request the JSON request from. Next step, I specify the request type. It's just a GET request. Okay. And next I'm going to set the retry number of retries. Okay, next in the method I'm going to compose my URI. This URI starts with /JSON/ and then ends with a get search IP method. The get search IP method is actually just a method that gets the user response. As you see in the application, user would type in a host name and this simply returns the host name as well as the format the request and the format that the JSON request requires. Okay, next we're going to send the request. So I'm going to call the send method, and then after we call the send method, we're going to get a JSON stream back. Now this is another important part of the framework, is that we provide a set of helper classes that serializes the JSON request, which is just a string, into a strongly typed Java object. In this case, it's our response object. And we have the JSON being serialization helper class that we're invoking here to basically get the response and convert it back into the Java object. And that's it. Well, okay, now let's look at how to cache data locally on the device. Local data would typically be cached in a SQLite database that resides on the device. So let's first understand what a SQLite database is. SQLite database is an embedded single user database that's optimized for mobile. It is lightweight and quick to create and is available on all major mobile platforms. SQLite database acts as ADF mobile application's persistent store, as it will cache data on the device regardless whether the application is running or not. Data cached in Java objects are destroyed when the application stops, but data in the local database will persist across application starts, and in some cases, even application updates. The library to create and access the SQLite database is embedded in the ADF mobile framework itself, whereas the database file resides on the device's file system. The SQLite database is accessed through the familiar JDBC APIs. Now, to support data encryption, ADF Mobile also provides and embed a SQLite encryption extension within the framework. Mobile devices themselves do provide SQLite support as well, but encryption typically is not supported out of the box. ADF Mobile, in turn, would ensure data security by providing the extra database encryption layer out of the box. Please see www.sqlite.org website for details of SQLite, its limitation, and supported data types. Now, in order to use the SQLite database, the database file must be initialized by the application, as well as the schema objects such as tables. Typically, you will code the database initialization logic in the application lifecycle event listener implementation class. You will first try to connect to the database when an application starts. If the database file already exists, it will simply connect the database. If that doesn't exist, then it will create a new SQLite database file. In your code, you would typically execute a SQL statement by trying to access an important table in your database, where the table will always have some data if it's initialized. If the statement fails, you know the database schema has not been created, and you can simply run through the initialization steps to create a SQLite database. To access the local SQLite database data, you would typically access through Java objects through JDBC APIs. And you would access these data in the database through service object. Now once you create a service object, you can then expose these as bean data controls by right-clicking on them, and this in turn will allow user interface to access the underlying data and then invoke the service object and invoke the SQL statement to retrieve data. And here's a very simple example of accessing a database. We're actually looking at, we'll look at this sample a little bit later in the next demonstration. Alright, let's go through the HR sample application. Alright, let's look at an example where the application uses a local database. This is an example HR sample application that's shipped with JDeveloper. In the application, we first want to look at the application controller project, and we want to look at the lifecycle implementation listener class, which is executed when the application lifecycle event happens. We're going to look at the start method, which is triggered when the application starts. Typically, this is where you would try to initialize the database and connect to the database. Here I create a database connection, and then I do a select of a known database table in the database. It could be essentially any table in the database. And if it's not there, then we know that the database most likely doesn't exist, or schema needs to be initialized. Then we can basically go to the part of the application which is copyDB, and that's the method I would invoke to create the or initialize the database. Actually, what we do here is pretty simple. We actually embed a SQLite database file into the application, and then we'll try to write the database file into a specific location in the on the device. In this case, we're going to write to the application directory location on my device. All of the applications have 3 locations: application location, temporary, or document. We're going to put in the application directory and copy the file over. The application directory is a location where the file would persist even if the application has been upgraded to a new version. Okay, so it's a very simple operation to copy the database file from the project into the device. All right, let's go back up and look at the rest of the code. Now let's look at the DB connection class a little bit. Okay, and in the DB connection factory class, all we're doing is we're trying to get to that hr.sql, or I'm sorry, hr.db file that we copied over earlier in the application directory, and then try to connect to it. Okay, now let's look at how we actually access data from the local database. So first thing we'll look at is go to my view controller project and look at my familiar service object and data object. So this is under the HR package, and as you can see, I have a bunch of service object and data object correspond to the database schema. So in the database itself, I have a table called country, table called department, table called employees, and then in my Java part of the application, I need to create a data object for example, department, and then I need to create a service object that basically populates the department data from the local database. Okay, let's look at the department Java class a little bit. So in the department class, basically I have all of the attributes associated with the department table, and then I also have all of the getter and setters for the department data object, as you may expect. Then in department list class, this is where, and let's actually look at the execute method The execute method is where I actually make a connection to the local database. So the first thing I do is make a connection to the local database. I declare and instantiate a array list, and then basically I execute a SQL statement and then iterate through the record set. And as I iterate through the record set, I basically populate and add to the array list. Okay, here are some additional code I have to add at the end, and this is also very important. As previously explained, ADF Mobile framework expects all the data to be returned as an array, so at the end I need to convert the array list back to an array. Okay, at this point you can create a data control out of the department list Java class and then use it in your application. Now, to complete the scenario, typically you would actually populate a local database with data coming from a server. To do that, you may add another method in this class, and you would invoke it when you want to synchronize data. In that method, you would essentially invoke the web services either through data controls, or if it's SOAP or REST, or if it's JSON, then you will use REST Service Adapter as explained earlier, and then you will populate and write data to a local database. And then when the application runs, you still run this execute to get data from the local database and display that. And when you need to synchronize data, you would invoke the other synchronization method to actually write data into a local database from the web services. Okay, this concludes this particular session. Now, just to summarize the session, you see how you could access remote data to the web services. You also see the different types of data controls you can create to access data, as well as discussing the declarative versus the programmatic approach to access data services. Next, we talked about the concept of service object and data object, in general how to access data through the Java code. Lastly, we discussed how to initialize and access the local SQLite database, which provide data caching capabilities for the ADF mobile application. This concludes the ADF Mobile Data Layer session in the ADF Mobile Virtual Developer Day. Now, at this point, we'd like to invite you to join this large, vibrant ADF Mobile community. We have a pretty significant engagement through a variety of social media channels like Twitter and Facebook. However, there are two very important links to remember. One is www.oracle.com/mobile, which will link you to the ADF Mobile landing page on the Oracle Technology Network. This landing page contains links to all kinds of ADF Mobile resources you will need to create your application. Next, be sure to check out ADF Mobile team blogs at blogs.oracle.com/mobile. The blog not only contains useful articles and samples on developing ADF Mobile applications, it also contains links to more code samples and blogs from the ADF Mobile community. Thank you for attending the ADF Mobile Data Layers session. Bye for now.